Welcome back, everybody. This is the second video in a series where I create a new programming language from scratch using C. This is the state of the code as we left it off last time. What it does is we are allocating some memory for our function, and we are just straight up writing in the bytes or the machine code to that memory, and then executing this function. So let's see if this still builds. Everything is fine. So yeah, it does build. And we can try out to actually run it, which is build and rebuild. So I have it. Okay, we have it. It builds. Everything's good. So having a function which just returns a static value that we cannot influence in any way is not very exciting. So let's kind of go step by step and try to make this code more dynamic and do more things for us. Let's first do a bit of cleanup. We don't need that. So for now, I'll also remove it because we don't need it. And I'll change this type def to S64 to be more in line with what maybe people are used to. So here's the cleanup. Still built, I guess. Everything's fine. And now we can start to do the work. So the first thing is we now say that this definition is not this particular function, but constant S64. And what I'm going to do first is I'm going to create a function, kind of a function factory, just extract this code into there and make it so that we can create a function that will return any kind of constant for us. So let's do that. So we need something that will return constant S64, and it will accept S64. So value is S64 value, and then we'll stop here. So right now we are literally just going to paste this code into here and return our function. So it would be, we need to pass memory to definition, which is what we're doing there. So constant S64. Oh, remember. Great. Now we can say constant S64. The answer is I totally forgot the function name. Make constant S64. Okay, this is like this, and we do S64. Now we don't need the cast because cast has been now done for us in this helper function. And let's see if this still works. Okay, it does build. And we can do it. So great, this still works. I will add this to git index so we can have a saved state for this and continue further. So obviously we just extracted this thing, but we did not actually make it an end. So if I create a second test, that says we'll create a function that returns 21 to 21, expect 21. This is not the answer. Then I would expect this to actually fail. Right? Because we are passing this value, but we're not actually doing that. Let me reformat this a bit. I like to have my function formatted in slightly weird way. You serially, so basically just return value always goes in its own line, and then we have to the function, and every argument also goes in its own. It just makes it convenient to have really long names. And I think a big problem with C is that a lot of people would kind of try to get a lot of stuff on one lane, and it doesn't, and they just make names shorter instead of keeping them long and descriptive. So I like to do that. Okay. Now we need to actually use our plate. As I mentioned in the first video, we on the modern Intel and AMD processors, they use what's called little endian way to store bytes. So if we have our S64 value, that means 64 bits. That means it is 8 bytes, and it means that if we pass in our 42 as a value, that will be 42 and 0, 0, 0, 0, 0, 0, 0. Yes, this is going to be like this. And we usually bytes are written as in hexadecimal version, so it will be something like 0x, 0x, and so on and so forth. I actually want to keep for now this version of instruction that just only accepts 4 bytes, as you see. So I will change around, make constant S32, S32, S32. We can do the 64-bit version, but honestly, it's not really more interesting than what we have. So adding type definition, updating all this stuff, updating this stuff, just a bunch of replacing 64 with 32. And then, okay, fine. So yeah. So when we receive this value, I will replace this so it's more visible. So say we pass in this 21, that means it's also going to be in this kind of setup, and we can just try it out bytes one after another. But we either need to know what those individual bytes are, so we need to kind of extract each individual byte out of our 32-bit value, or we'll need to tell C compiler to do it for us, which is what we're going to do. So to say that so our immediate address, so this is where we would actually write our value. Immediate value is, so it should be located on the third byte of, or fourth byte, but third index of memory. But the memory is pointer to array of bytes, so we also need to pass this pointer to the type of text we want. So in our case, pointer to is 32. And in reality, this particular line is not present in the output. The only thing it does, it just tells C compiler to treat this particular region of memory as a 32-bit signed integer and allows us to manipulate it as such, but doesn't actually do anything else from the code perspective. Okay, so we have our immediate value, and it means that we can actually write to it. So we say, it says kind of write to the pointer, and say immediate value is that, and we don't need this stuff. Okay, let's see if that still builds. Okay, constant test32. Oh yeah, okay. Okay, first, did not actually update type definition. It's fine. Let's see if I was successful. Great. So now we have a nice function that we can call with any 32-bit number, and it just creates for us a function that we can call. We can also call it multiple times, right? So we can just say, yeah, we can call it again, and it's still gonna do the right thing. And this is pretty neat. Again, not much use for this right now, but as we get further in the language, these kind of functions that kind of return you back a constant value is actually something really handy, and this is we will use it quite a lot. But right now, again, let's add it to the Git index. So we have it stashed, and we know that we had a state that works. And go into the next big topic, which is would be very nice if our function actually also could accept a value, not just return hard-coded one. So we'll create another test. And again, at first I will not create a helper function, but it will just write everything in line. Create a function that returns 64 value that was passed to it. So basically, what we want is we want our code to generate something like this: S64 ID or identity. So identity just means that this is a function that returns exactly what was passed to it. It's a terminology from functional programming, but we are going to use this. So again, this is a very exciting function to to exist, but it allows us to work through the process of getting a value out of the argument and returning that value. And there will be actually several iterations of this stuff because of how all this works, which we'll see in a second. So we want. Let's actually go and take a look in the compiler explorer what that would look like. So okay, it's fine. We want our function. Obviously, to complain that it has no idea what are those types, so we need to also end types. Let's see. Okay. So this is what the assembly for this looks like, and it's actually kind of interesting. It's not exactly what I would expect to happen. Oh, okay. So it might be because we are compiling without the utilizations. It's okay, doesn't matter. So what does it do? It says I want to move a value out of this register into this memory, which is stack pointer plus 8. Then it's, I believe it takes the, yeah, then it loads that value back into array-x register, and basically this is the same as we would have. So like whatever is in array-x register, this is what is returned to the caller. I think right now is the good time to kind of show and also remind myself how do you know all of that? How do you figure out what should go where, and how this function call is actually structured? For that, we can again go to MSDA and say x64 calling convention. Sure, there's a convention that they need to look at, but let's see. Yes, I believe this is, yeah, we need this one. So this page is actually quite neat. It explains exactly like sort of what goes where and how we are supposed to, how do we put values that are arguments into necessary registers on stack so that the function that we call can find them at the right place. And as we can see, like right now we are just dealing with integers. We're not going to touch floats or like mixed types or big types. So for now, let's just stick to integers. And this is exactly what they're saying. So when you have a function that receives integers as parameters, then the first parameter that it receives needs to be inside RCX register. And if we go back to our compiler explorer, like this is sort of where it is. The reason you have this saving, I believe, is because of debuggability. Like you want to save the parameters on stack, but I'm not sure. In reality, you could have totally done move array-x RCX, and I think this is what we're gonna do in our version. So we are just kind of taking this parameter, which is RCX, and put in return value. Let me see where they say about return value. Yeah, return value. So return value that can fit into 64 bits is returned through array-x, which is exactly what we were doing. Right. So we just need to things. So we want to move into array-x whatever we had in our RCX registers. It's 64-bit assembly. Great. Very simple command, and we can do that. So this is what our function is supposed to do. And then this is move array-x RCX. Great. So let's try to do that. And we need this stuff. It's fine. And same as before, we are just gonna take the bytes of we got from this nice assembly and just put them in. And now we need to pass this to the type that we want. Let me actually do the type def right away. Type def. This will be identity S64. S64. Great. So we are saying that S64 result is identity S64 of memory. we can call it with 42 as usual. Let's check if result is 42. So I probably made mistake somewhere along the way, so let's see. It did not. And this does not work. Okay, yeah, it does not work because I forgot to return, which is very important. So right now, it basically like executed this instruction, which is what we want. So it dutifully took RCX and put it in regex, but then it started just executing random memory, which is very, very bad. So we should never forget return. Great. Turn. And let's try that again. Yay, we have 42 that is returned to us. Okay. Let me clean this up and firstly add to index, and then I will clean this up and create the same sort of setup as we had for the constant version. So we have now identity is 64, identity is 64 is 64, and here we don't need this. Instead, we need these bytes. Again, open. It's fine. And then we have AG64 is make identity S64. Here we don't need a value, so because this thing just returns whatever we will pass to it. We don't need any of this. And finally, let's clean this up. So ID as 64 of 42. Yeah, that's incorrect. We need to cast it to this. It's fine. Great. Okay, everything works. I think that's enough for this episode. Thank you so much for watching and see you next time.